Welcome to my page. Today we are looking at still logarithm with tables. We have question 1 to 3. Let's add to them straight away. Number 1, we have the fifth root of 6.838 raised to the power of 3. So we draw our table like this. This is number and this is logarithm. Okay. So we have 6.838 raised to the power of 3. Everything raised to the power of can be written as this in indices. The fifth root of this number can be written like this. So what we do, we convert this thing to standard form so that we write down the power of 10 as integers. But for this, the point is already between the first two numbers, and we have 0, nowhere to move it to. So what we do, we go to our logarithm table. We look for the logarithm of 68 under 3 difference 8. So we look for 68. See, this is 68. 1, 2, 3. This is under 3. Then difference what? Difference 8 is here. 5. So that is what we are going to do straight away. So 68 under 3 is 8344. What is the difference? The difference 8 is 5. That's what we have. We'll add it. That's what we learned in the previous video. We have 9, 4, 3, 8. You write this straight away. 8, 3, 4, 9. Multiply it by 3. This 3 inside. The power inside, you multiply it by 3. Okay? So, what we have? We multiply from the right to the left. 3 times 9, we have 27. Write 7 carry 2. 3 times 4, we have 12 plus 2, that is 14, carry 1. 3 times 3, we have what? 9 plus 1, that is 10, write 0, carry 1. 3 times 8, we have 24 plus the one we carry, 25, carry 2. 3 times 0 is 0 plus 2 we carry, we have 2. This is what we'll divide it by 5. This 5. We divide it by 5. What do we have? So we divide from the right to the left, from the left to the right, while we multiply from right to left. Okay, now we have 2 divided by 5. Cannot. Write 0, shift the 2 to 5, which is 25. 25 divided by 5, we have 5. 0 divided by 5, 0. 4 divided by 5, cannot. Shift it to the nearest one, which is 47. 47 divided by 5, we have 9. Remember what? 2. You discard it. Okay? So this is what we'll look for the antilog of this. So remember the integer part. So now we are going to learn our antilogarithm table. We look for 50 under 0 difference 9. 50 under 0 difference 1. So if you look at your 50 here, this is antilogarithm table. This is 50 under 0 difference what? 9. 9 is here. See the difference? 9 is what? 7. So we write it log, and under antilog table we have 3162. Difference 9 is 7. You add it to get 2 plus 7. We have 9613. So remember, it's 0 point this number. So we have 0.3169 times 10 raised to the power of the integer part is what? 0. 0 plus the extra 1 you need to add always. Remember this. So we have 0.3169 times 10 raised to the power of 1. So this one will make you move this point one time. Convert it to ordinary number. We have 3.169 as the answer. Okay, so let's do number 2 straight away. This one is our usual number. We have number 2, the cube root of 0.0312. That is our number 3. The cube root of what? 0.031. So we write our table, number, and logarithm. So this number can be written as 0.0312, everything raised to the power of 1 over 3. So what do? We convert it to the standard form and take the power of the 10 as the integer part, which is 1, 2. Because we are moving it from behind, that is minus 2 bar 2. So we'll go straight to look for logarithm of 31 under 2. No difference. Logarithm log 31 under 2, but no difference in this time. So we check where is logarithm of 31. Logarithm log 31 under what? Under 2 is this. 49, 42. 49, 42. So we write it 49, 42. So you write it straight away because there is no difference. 42. So, but mind you, we need to divide it by these 3. So you write divide by 3. 3. But in this case, it's not ordinary number like 2. That you say 2 divided by this cannot shift it. No, we are not going to shift anything in this place. So rather, we find a way to make this place divisible by 3. Either by increasing the value to 3, but you still maintain this minus 2. Whatever we increase it to, make sure the result will still give you bar 2. Like for example, we are going to add 1 to it, like bar 3 plus 1, which is the same thing as minus 3 plus 1 will give you minus 2, which is bar 2. Do you understand? That is what I will give you more example on this. But for this, follow me on this one. We have bar 3, like I said, plus 1.4942. Okay? Divide by 3. That is what we'll do. So, bar 3 divided by 3, we have bar 1. This one, 1 divided by 3 cannot, that is 0. Even if 0 plus anything is still the same thing, so you put your point. Shift it to the next number. 14 divided by 3, we have 4, remainder 2. 2 in front of 9 is 29. 29 divided by 3, we have 9. We have 9. Remainder what? Remainder 2. Because 9 times 3 is 27. Then, well, is 29. So, remainder 2. 24 now. The 2 will be in front of this 4. 24 divided by 3. We have 8. 8. 2 divided by 3. Add 0 to still be 20 because point is already there. Divide by this, we have 18, 6. So you can leave the rest. So of no use. So what we have here, we have this number here to look for the antilog of this. So that's what we are going to look for. Antilog of this. Let's see what we'll have. Okay. Let's see what we have, whether it's going to be compatible for us. So we have antilog of what? 49. 49. Let's take it again. Let's make sure this number is correct before we check the antilog. We are dividing this. We have by 3. 14 divided by 2. 14 divided by 3. We have 4. Remainder 2, which is 29. 29 divided by 3. We have 9, which is 27. So let's look for the anti-logarithm table. Under anti-logarithm table, we are going to look for 49 under 8. 49 under 8 is what? 49 under 8 is 31, 31, 4, 8. Difference what? Difference 6. Difference 6 is 4. You add it. 12, 5, 1, 3. So we have 0.3152 times 10 raised to the power of minus 1, which is minus 1, plus 1. You must add this always. Don't forget, you need to add this always. So that is it. You must add this. So let's see. We have 0.3152 minus 1 plus 1 is 0. So we have 10 raised to the power of 0. So we are not moving this point to anywhere. We have 0.3152 as the answer. You understand? So let's solve the next one, which is the last number. The last number, we have root 4, the fourth root of 0.00237 raised to the power of 3. So let's see how this goes. This is the question. The fourth root of 0.02371. We have our usual way, number and logarithm. So let's write this 0.02371 raised to the power of 3 or raised to the power of 1 over 4. Or raised to the power of 1 over 4. We have, we need to convert this to standard form. 1, 2, that is bar 2. We have bar 2. So we look for 23 log 23 under 7, log 23 under 7, difference 1. Log 23 under 7, difference 1 is 37, 37, 47. Difference 1 is 2. So we add it. 7 plus 2, we have 9, 4, 7, 3. So we have 3, 7, 4, 9. Multiply by 3. Multiply by 3 before we divide it by 4. Always divide the logarithm after everything by the roots. The root is always division, while the power is multiplication. So we have 3 times 9, we have 27. carry 2, write down 7. 3 times 4, 12 plus 2. 3 times 4 is 12 plus 2 you carry, that is 14. 3 times 3, 21 plus 1 we carry, that is 22. 3 times 3 is 9. 9 plus 2, that is 11. Carry 1. 3 times bar 2 is bar 6. Plus 1 we carry, we should make it bar 5. Do you understand? So we have point bar 5. Point bar 5. That is it. Are we following? So let's do it again and make sure it is right. 3 times 9, 27. Take away 2, write down 7. 4 times 3, 12. Plus 2 we carry, make it 14. Write down 4. 3 times 7, we have 21. Plus 1 you carry, 22. Take 2. 3 times 3, 9. Plus 2, that is 11. Write 1, carry 1. 3 times this, 6. By 6. Plus 1 we carry, and we have this. So let's divide this by 4. We divide this by 4. So how are we going to do it? We need to rewrite this number. We will write this number to make sure 5 divided by it does not have a point or a decimal number. It must be a whole number. So we have, how do we make this to still remain and be divisible by 4? We have 8. Bar 8 plus 3 is still the same thing as bar 5. Bar 8 plus 3 is still the same thing as bar 5. 0.1247 plus 1247. So that is it. That is what we need to do. So divide by 4. So by 8 divided by 4, we have by 2.3 plus, when you 3 divided by 4 cannot, because this is positive already. So 0. 0 plus bar 2 is still remain bar 2. So we have 31. 31 divided by 4. What will be the answer? We have 7 7 7 7. So 7 times 4 is 28. Now remember 3. Take it here again. We have 8. 3 into here, we have 32. 32 divided by 4. We have 8. We have 8, 8. And this is 1. This is 1. Are you following? So what we need to do is to find the log of this. Let's cross-check so that we'll be sure of what we have done. Bar 8 divided by 4, we have bar 2. 3 divided by 4 cannot. Shift it to 1. 3, 1 is 31. 31 divided by 4, we see 7, 7. Because 7 times 4 is 28. So remember 3. The 3 you shift it to this, becomes 32. 32 divided by 4, we say 8, 8. 8, 8. 8 times 8. 8 times 8 is what? Is 32. So let's go straight. We look for antilog of 78 under 1 difference 1. Antilog of 78 under 1 difference 1. 78 under 1 is this. 78 under 1 is 60. It's what? 60, 39. 60, 39. Under 1 difference 1 is still 1. So we add 0, 4, 0, 6. So what we have is 0, 0.6040 times 10 raised to the power of what is the integer part, bar 2, which is minus 2 plus 1, the normal one we used to add. So we have equals 0.6040 times 10 raised to the power of minus 1. So we'll move this point backward a little once, which is 0.00604 as the answer. So I think with this, we can attend to many of the questions. It will be easy for us to do. So in the next video, I'll talk more on the complex one. Let's see how we'll go about it. See you in the next video. Thank you.